Alrighty. So welcome back. Very glad to have you guys be excited enough about this to submit yourself to it twice. Um, so last time we covered a bunch of stuff. We covered getting data into Stata, getting data down off the web, sort of in a command-driven way. We did a bunch of data manipulation and data changing, creating new variables, all that sort of fun stuff. Today, our goals are modest. We're going to try to help you combine data sets in two different ways. And the main two ways, maybe the only two ways. And then we're going to jump over to some plotting and some loops. These are definitely a step up in terms of the challenge of how to do them, but very useful, very uh, fun tasks that make you feel like a real programmer. So I'm going to try to go slow, but hopefully you can stick with me. And if you don't, just shout out and let me know. Um, and I'm glad to answer any questions as you go. And if you guys have requests or Q&A at the end again, I found that relatively useful. So let me start sharing my screen. Okie dokie. Let's put that in there. Okay. Stata window. Alrighty. So let's start off. I know I told you earlier that you don't have, or that you should have a DTA file, but let's just, for the sake of things, let's start back where we were. Okay, so let me see here. So you might remember that we were using this HD 2018 data. So hopefully you still have that on your screen somewhere, and or on your computer somewhere. Hopefully in the same area that you had everything else, from the um, sorry, I'm having a hard time resizing here. So from last time around. And so if you do, let's just go ahead and re-import that. Hopefully you remember import delimited. I made you do it ad nauseum last time, but hopefully it's still drilled into your brain. So if I go ahead and press import delimited, I get I get my data in. This is you'll remember the institutional characteristics. So we have things like the institution name, the address, the city, a bunch of other things about it. Last time we were looking at sector a little bit. So we were creating region variables and changing the value of the region variable depending on what state a state was in. We're not going to use that state stuff again. So if you didn't get to that, no worries. The other thing we did was we had this sort of set of sector labels that we wanted to add. You can feel free to add the labels if you'd like, but I think the main thing that we should be interested in here is just getting the sector label, or just looking at the sector. So you don't have to have the labels. I can put the labels on, and we can do that with or without labels. I'll put them on, and that can help us keep track of what's what. It's not going to be super important, but in general, it'll be useful for you if you want to use it in the future to have labels on things. All right, so okay, that's kind of where we were. The one thing I want to make sure that I reinforce for you and that you have is this saving a data set. So we made a few changes to it. In this case, there's one more change I want to make sure we make before we save, and that is this part here that I have up here. We did last time, which was we limited ourselves just to the instances where OMCHRT is 50, and we remember from the documentation that the 50s were the totals, right? So across all the schools. So we're going to go ahead and do that. We're going to limit ourselves to the 50s. So why don't you go ahead and write that out if you can, or if you can find that code. um, uh, go ahead and find that code. And Naomi, I know I told you before that I was going to keep the same do file, but it's already looking too messy. So I'm going to, just to clarify things for you guys, I'm gonna go make a new do file. So I'm gonna press a new one. I'm gonna say file, save as. Stata tutorial. I'm gonna say intro Stata tutorial D2 or day 2. And then I'm going to grab my import command. So I'm going to put the boilerplate up here. So I'm going to say CJ Bossy Stata tutorial day 2 6 15 20. Remember from last time that the stars make comments, so Stata won't read those. This is just some boilerplate code that goes on the top of all my Stata files. So clear all clears out everything, set more off, sets the off option, or sets the more option to off. And then I'm going to just import the data. So I'm going to import school characteristics. And I'm, so that if I run this, I import all the school characteristics. And then I'm just going to pull my labeling values in here, and I'm going to pull in my keep if the cohort is 50. So we keep just the totals. So I'll write this in here. Keep just total values. Okay. Oh, you know what? I'm sorry. We don't need to keep it OM cohort yet. That'll be later. That's for the other data set. Okay. So I've got this, and then all I'm going to add here is my save. So we're going to save this file as a DTA, a Stata data file. So I'm going to save it in my Stata tutorial folder. I'm going to call this iPads directory 2018.dta. So it's save, then the path and the file name, close quote, comma, replace. And I'm going to pause there and just make sure everyone's with me. So can you give me a thumbs up if you've successfully imported and saved a version of the file? Okay, I see one thumbs up. This is a small enough group that I'm going to wait for folks. Hopefully folks can get where they need to be. And if you have questions, just shoot me a line, and we can try to troubleshoot for you on your end.
While we're waiting, can you just drop that label define code in our chat for us, please?
Yes, of course. Yeah, of course. That's a good idea. It's gonna look funky in the chat, but you should still be able to copy it over to your do file. No problem. I'll give folks. Why don't I give folks 2 minutes to do this, and then if folks still aren't feeling comfortable, we can proceed. Or sorry, we can troubleshoot, and then if folks want me to just, I know it can feel also like a really annoying thing to have someone waiting on you. You feel not totally on top of it. So
can you remind me again? I am trying to import, but it keeps going to the wrong folders. Can you remind me one more time how to change the folders in
yeah,
code?
totally. Yeah. So 1 second, let me just set this timer. Okay. So always fun to know this is recording so I can embarrass myself. Okay, so you want to see what your current directory is, you type pwd. If you want to change that directory, you can type out, like, say, if I wanted to go to my downloads folder instead, with remembering that if you're on a Mac, you're going to do that / first rather than the C:\. So users C Labasi downloads or something like that. And I usually always put the last / there too. And then now I'm in the downloads folder, right? If I wanted to change back, I could say C:\, users. Yep, no problem. C Labasi documents. Stata. Okay. No problem, Lexi. Thanks for joining us. We're hopefully hopefully this will be useful for you. I think it will be.
Very excited about loops.
All right. Well, I hope I do them justice. Okay, so I think that we are. I think I've lost my timer. Here it is. Okay, we've still got a little time. So take your time. Open up any questions if you've got any questions. I take it that the thumbs up aren't persistent, like they don't stick around, and so
we could do raise hands if you wanted instead. Those stay up.
Those stay up.
Yeah.
Nancy, what would I do without you? Okay, that's great. Yes, if you want to raise your hand then and let me know that if you're. Let's just say it's good to proceed on your end. So whether or not that means you feel like you've got it or not. Okay, I won't make the bomb go off here. So, okay, so those of you who don't feel like you're ready to proceed, just shoot me a line. If not, otherwise just, and you can shoot me a private line too, if you'd like. Oh, yes, yes. 1 second, Ash, and I will give you that link. So, so the HD data we got here. So if you put this in, you should be able to get that. Sorry, you gave me a thumbs up before, right? So I should be counting you as a good ready to proceed. All right, team. I don't know if I lower your hands myself or if you can lower your own hands, but if you can lower your own hands, why don't you go ahead and lower them? Okay, so so at this point, what you should have is some code that imports that data file, that CSV, labels it if you feel like it, and then saves it to your computer, hopefully to the same location or to at least a location that you feel comfortable with. And so that's great. So now we're done with this file for now. okay? But what I want you to do is imagine that you wanted to also add the 2017 directory data. I don't know why, but maybe you'd want to be collecting all the directory information for every college to look at how addresses have changed or if colleges have moved or whatever it is that you wanted to look at. And so you wanted to get the 2017 data. So as a reminder of how to do the copy command, I'm going to ask you to go ahead and find the 20. Actually, I'll just give it to you because I don't want you to have to go back to the iPads data center. There's no reason. You should know about the iPads data center. So I'll give this to you, but I want you to go ahead and do the same thing, same sort of importing thing with the 2017 data, which you can get at that address. So I'm going to start putting it into mine, and we're going to import the 2017 data as well. So you're going to go through these steps, and then you're also going to do the import. Okay. So let's take a couple minutes to do that. Okay. So hopefully now you have gotten that downloaded. I'm going to just go ahead and do my importing as well. Hopefully you're getting close on this too. And I'm going to just change this from 2016 to 2017. So here we go. I'm going to do all my copying, and you can see it copying. Now I'm importing, and I've got that file imported. Okay, so now I'm on the 2017 data. Great. And so one question is, if I want to add, let me look at this data real quick. So I'm going to browse, and I can see, okay, this looks very similar. I've got a bunch of columns that look exactly like the columns that I had in my 2018 data. And all I want to do is add this to the bottom of, or the top, whatever you want to think about it. But I want to combine the two data sets vertically, basically. So I want to take it so that the matching columns get combined together, right? So the thing that they have in common is the columns, not the rows. I mean, it is also true that the school names are often the same, but in this case, what we're interested in is the yes, Naomi, you should replace the data in Stata's memory with the 2017 data, yes. But that's, remember here, using comma clear with import delimited will automatically clear that out. So if you don't do that, Stata will ask you about it, I think, or will tell you, no, you can't do it because you don't want to replace the data in Stata's memory. But in this instance, we do want to clear it out. I promise it's fine. One way we know we want to clear it out is that we've already saved a copy of that in Stata version, and so it's very easy to get back to it. But of course, it would also be very easy to get back to it just by importing the data again. So we're not in any danger. Okay, so we're going to import the 2017 data, and we're going to try to add the 2018 data to the bottom of it because they have in common the columns that they share, and that's the thing that we want to do. In a second, we're going to look at combining things that have rows in common. The reason we don't want to think of these as having their rows in common is that while they are, many of the same colleges, they're the same colleges in different years. And so right now we're just interested in combining them sort of vertically. And so the command for combining vertically is append, and we're going to say append using, and append allows us to append only Stata data files. So that's why we had to save a Stata data file. And all we're going to do is feed this the append using. We're going to feed it the IPEDS directory file from 2018 that we just saved before. Okay, so if I do import delimited and then I do append using, you, like me, will probably get this error. Okay, and I want to show you this error because it's a very common error that you get with append, and it can be quite baffling how to solve it, and could be a real roadblock for you if you don't know how to solve it. So what it's telling us is that the variable OP_ID is string 8 in master, but long in using data. You could specify append's force option to ignore this string numeric mismatch. The using variable would then be treated as if it contained a blank. So a few things that you might remember from our last class here. So the first one is that the variable OP_ID is str8. So that means it's a string variable. I hope you remember from when we do describe. I can prove this to you here. So describe OP_ID, and we see that that's a string. It's a curious thing because when we look at OP_ID, I'm just going to look at the first 5 versions of it, or let's look at the first 10. List OP_ID in 1 through 10. So that'll show us the first 10 things. Looks like it's all numbers. Maybe there is a non-numeric character. So to check for whether or not there's a non-numeric character in here somewhere, we can say list OP_ID if real paren OP_ID equals period. So, okay, what's going on there? That seems like some black magic. So what's going on there is what we're saying is I want you to list the observations for OP_ID if the real number value of OP_ID is equal to missing. So what this is going to do is it's going to go through each observation and it's going to say, okay, what's the real number value? If I pretend this is not a string, even though it's stored as a string, if I pretend it's not a string and convert it to a numeric value, a real number, what happens to it? And if it is convertible to a number, it just spits back the number to you. If it's not convertible to a number, aka it has a non-numeric character in it, it will give you back a period or a missing, right? It says that value doesn't exist. And so what this is going to do is show us the instances where the values of OP_ID are not real numbers. I should spell it right. So there's a couple of instances here where maybe there's a blank with a space in it. These are different values where maybe there's a space in it. One thing we could do to get rid of that is to use the string trim command. And that gets rid of, or the string trim, so we would say something like replace OP_ID equals strtrim OP_ID, right? And that will get rid of those. That made those 3 real changes, got rid of those extra spaces. But luckily also Stata will by default get rid of those spaces if you use a dstring. But the basic problem here, to go back to what's going on, is that our OP_ID variable currently is string in the master data set. So the master data set is the data set that's currently in Stata's memory. But it is long, or it's a numeric form, in the using data. So remember, the reason this is called the using data is that we said append using, right? And the data that follows the using command is the using statement is the using data. And so this is the master data, this is the using data. The using data has always got to be in DTA format. That just means Stata data format. But in this case, when it's stored in the other data set, it's stored as a numeric character. And in our data set, it's stored as a string character. So, or as a string value. And so those things don't go together well. And so we have to make it so that the OPID is a numeric, so it matches the other one. Fortunately, here that's pretty easy. It can be thornier, and you'll have to play around a little bit more in many instances. But for the most part, hopefully it should be fine. And so we'll say dstring OPID, comma, replace. Okay, the dstring command takes a non-string variable, or sorry, it takes a string variable and makes it numeric variable. So if we do this, what we get back is OPID, all characters numeric, replaced as long, 3 missing values generated. So these 3 where there was a space instead of a number have now been changed to missing, and we've got a numeric character. So now when we run these 3 lines of code, or you could just run the append, we see that it appends with no problem. Okay. And the other thing we see is that whereas before, I can actually open this back up and show you, I import delimited. If I describe and look at the number of observations, I can see that I have 7,000 observations. When I dstring and add the other data set, now I have now I have 14,000 observations. Okay, so roughly doubled. That makes sense. There should be roughly the same number of colleges in the U.S. At one time, or in a given year, over across years. They should be pretty steady. Although that may unfortunately change in the near future. Who knows? But in any case, we've successfully appended 2 data sets. So let me pause for if you guys have any questions about appending data sets. Okay, Naomi, are you getting this error that we were getting before that I'm showing on the screen? Okay. So did you specify, first of all, when you did the import of the 2018 data, did you at the end of that save it to a specific location where you're specifying the path that you're saving it to? And then did you refer to that same path and that same file name when you did it append using? So the thing that I'm doing here is I'm bringing that same data set that I saved up here and attaching it to this new data set 2017. No problem. There's often some, typo or some small thing that's going awry. Sometimes you just have the code in your do file and you forget to run it or something like that. But let me know if you have any other problems. Okay, let me go back to my reference sheet here. So
So what
all
we've
right.
just what we've just done is just stacked rows on top of each other. We haven't merged. We haven't needed to connect anything yet.
That's right. So we stack the rows on top of each other. It's a type of connecting that we like to do, but yes, we haven't said like I've got Bradley's information about his grades in this one file, and I've got information about his I don't know medical history in this other one, and we're going to try to put them together. Right? So this is matching on columns. The next thing we're going to do is merging, which is matching on rows. Sometimes you hear this called vertical concatenation, and what we're about to do, horizontal concatenation. Okay, so horizontal concatenation. So let's just import again our 2018 file. No need to do the CSV like I do. If you prefer to do the the, sorry, if you prefer to do the DTA, that's totally okay too. And then, you know what, actually, probably we need to go back and do this another way around. So why don't we actually re-import the OM data? So there we go. Okay, so we've got this outcome measures data. I want you to bring that back in. Naomi, I'm glad you solved it. Was it something small like a typo that just makes you want to jump out a window? It always happens. Okay, so so I'm going to re-import this OM data. Okay, I'm going to just remind myself what it looks like. We've got the unit ID and the OMCHRT and all these sort of the imputation variables, yada, yada, yada. And there's a few things I want to notice about this. So first of all, let's go back to what we had before where we were going to keep if OMCHRT equals 50. Remember 50 are the totals like I was saying before. This was the part I wanted to do it in, not the earlier part. So we're just going to keep those. And I can see now if I browse that I only have OMCHRTs of 50. Okay. So that's, you'll remember, this is what we learned about keep, which if we want to keep observations, we have to specify the if statements that meet the criteria that allow you to stay in the data set. Okay, so I've done that. And now I want to take, I've got a bunch of university information here that's about the number of students who receive a bachelor's degree and receive an associate's degree and receive a certificate from a given institution after 4 years, after 6 years, after 8 years. And I might want to add on that information that's in my other data set, which is the directory information. For example, I don't know the names of any of these colleges, right? All I have is an ID number and all their data, right? I don't know the locations of any of these colleges. I don't know the sector of any of these colleges. And so if I wanted to add that data on, I would need to match each college to the appropriate data that is in the same sort of row, right? So, but we don't know which row everything is in. We don't have any reason to assume that the rows are in the same order in the two data sets. And so what we have to do is have to find a common identifier, right? This is the problem that your social security number solves, right? Is that even your name doesn't sufficiently distinguish you from other people in the country, especially if your name is, you know, John Smith or something. And so it really helps to have an identifying number that disambiguates you from everyone else in the world. And colleges have, most data sets have these identifying variables that allow you to distinguish which college belongs with which other college across multiple data sets. So that's what we're going to try to do here. Samuel, go ahead. What error are you getting? Interesting. So are you using import delimited for a CSV file, or are you using the DTA file for OM 2018? Sometimes it gives that error if you're sort of using the wrong import file for the wrong type of file. So if you're importing the DTA file, you should be using the use command. It's a 27 data and you unzipped it and it's a .csv for sure. Can you send me the command that you put in when you imported it? And while Samuel's doing that, the rest of you, are you guys feeling like you're up to pace so far? Just like give me a thumbs up or something if you feel like you're staying with me. Cool. Okay, great. Thanks, Samuel. All right, so so we've imported this file. We've saved just the totals for the file, and now what we want to do is match on the the directory information. Okay, so the unit ID here is the identifying variable, the variable that allows us to distinguish all of the schools from each other and allows us to match their data together. And so one thing that's really important is that we know how does this actually uniquely identify the data from in the data set. So is this unique to each line? And so so one way to do this is to write duplicates report. I can't remember if this is a user written command or not, but hopefully it is not, and you can use it. If it isn't, then you know how to install user written commands. So it turns out duplicates report tells us if there are how many copies of each unit ID there are, and there's only one copy of all of them. Okay, so that's really nice. There's another neat command that is just a very simple command, and it's called isID, and it is basically tests whether or not something is an ID variable, meaning that it only appears once in the whole data set, and it returns no error if it is an ID, and it returns an error if it is an ID. So I just want to give you a sense of what this looks like in instances where you don't have to do what I'm doing here. I'm just going to show you real quick. In instances where it's not unique. So if we didn't limit ourselves to the OM cohort equals 50, what we would end up with is multiple rows per unit ID, because we have not just the University of Scranton's totals, we also have their numbers for the first-time full-time students specifically, and then for non-first-time full-time, and then for non-first-time, non-full-time, right? All the different subgroups, all for all Pell students, right? They appear multiple times, and so so when we say duplicates report unit ID, oh, I should spell it right. Duplicates report unit ID. What we see is that 220 observations have their unit ID appear 4 times. 702 observations have their unit ID appear 6 times, right? And there's a bunch of different instances where there's multiple copies of the same piece of data, and so that makes life a little bit more challenging sometimes. But for now, we're going to make life a little bit simpler, and we're just going to keep our just the one. And so again, I can say, oh, you know what? I meant to show you also what isID looks like when you have multiple. So let me bring that back in. So here's what isID looks like when you have multiple. It says variable unit ID does not uniquely identify the observations, right? So if you don't get that error, if you don't get any error, it is a unique identifier. If you do get an error, it isn't. But I kind of prefer duplicates report just because it's a little bit more explicit. Okay. Okay, so I'm gonna drop this again for the millionth time, and now we've got one. Each row is a unit ID. So I want you to trust me that in the iPads directory DTA, it is also unique by unit ID. So unit ID is also an identifier. So the thing we're gonna try to do is we're gonna try to merge this data on to our outcomes measures data. So the directory data onto the outcomes measure. So I bring, I'm just bring. Sometimes nice to build with building blocks. I'm gonna bring the DTA down first and start to jump into building out this command. So the first thing I write is merge. The next thing I write is 1:1. Then I list the variable I want to merge on. In this case, it's our identifying variable of unit ID. And then again, I say use it. Okay, so what's going on here? So merge is the command. It tells us I want to do a horizontal concatenation. I want to smush rows together rather than smushing columns together, which we did before with append. So we're going to smush rows together. What this is telling us is that the key variable here, the unit ID that's going to match the variables to each, is unique. So there's one copy of it in the like the data set that's already in memory, and there's one copy of it in the data set that's going to be coming into our data. So this, in the parlance of Stata, is the master data set. The one on to the left of the colon is it unique in the master data set? If it is, we put 1. Is it on the right side of the colon is it unique in the using data set, right? The data set that comes after using. Is it unique in the using data set? If it is, we put 1. What about if it's not unique? So we could put M after. So that's if it's not unique in the using data set, or if it's not unique in the data set in memory, the master data set, then we put an M there. Now, everyone, like with completist minds thinks, oh, what about the M-to-M thing? This obviously is very problematic. Hopefully, maybe it's not obvious, but it will eventually become obvious. You'll see people making jokes about M-to-M. If you hang out on the wrong parts of Twitter, you'll find people making jokes about M-to-M merges. And unfortunately, I'm on those wrong parts of Twitter. But the M-to-M merges, it's the whole point of merging is that there's some identifier that allows me to match this line in one data set to this other line in this other data set. And if you have many copies of each of them, then you don't know which lines go with each other. So the M-to-M, even if you look into the Stata help files, so if we say help merge, you can see many-to-many merge on key specified variables. And then if you go down and look at the explanation of the M-to-M merge, let's see if I can find it. There is like a very funny, I guess they've maybe taken it out. There used to be a very funny warning against using the M-to-M merge. And they basically say it's only here for programmers. So you're never going to use an M-to-M merge. At most, what you do is M-to-1 or 1-to-M. But in this instance, the easiest, simplest case is merge 1-to-1 and unit ID using IPED's directory 2018. Okay. Yes, when I say it is unique, Garrett, I mean the unit ID is unique. So so in this instance, right, like we said, duplicates, report, unit ID. There's also a unit ID variable in the IPED's directory data. In fact, let me just prove this to you. So I know you trust me, but let me just prove it to you. Import delimited HT 2018. And so then we say is ID unit ID. We don't get an error back. If we say duplicates report unit ID, we see there's 6,857 copies. Okay, so one thing we notice is that there's 6,000, basically 7,000 copies of unit IDs in this data set. But when we go back to this data set after it has been limited, what we see is that there's many fewer observations here. Right? There's 3,818. So obviously there's not enough in both data sets for it to match exactly, but that's okay, and that's important. Part of what happens with merging is that you don't always match every case. Sometimes people or institutions or whatever are in one data set but not in the other. And keeping track of who's not in what data set or who is in what data set and why they aren't matching is an important part of your work as a data analyst. Okay, so I'm going to do this merge. I'm going to execute this merge. Hopefully you can too. And what I see here is just like what I said. So you get a nice little result that tells you what happened with your merge. So the first thing you see is that there were 3,039 observations that were not matched. 0 of those unmatched ones came from the master data set. 3,000 of them came from the using data set. That makes sense because there were 3,000 more observations, 3,000 more unit IDs in the directory file than there were in the outcomes measures file. And then there were 3,818 that were in the in both data sets, and so they merged. This creates a new variable called _merge. And this sort of gives you a sense of what values get paired to which. So if we say tab underscore merge, we can see the using only data, and they get tagged with this. And we see the matched data, and they get tagged with this. Okay, and these numbers line up as before. One thing to know is that if you want to do another merge after you've done a first merge, Stata won't let you have two variables that are called underscore merge, and merge automatically generates this new underscore merge variable. You can suppress that if you want. You can look in the help file for how to do that, but mostly what people do is they keep it just so they know what happened with their various merges, because merges are a big source of data confusion, uncertainty around why something went wrong, yada yada yada. And so people like to be able to go back and investigate where a merge might have gone wrong. And so what a lot of times people do is say like rename, or what I do at least is rename underscore merge one or something, or a merge with a name, right? So directory to something like that, right? And then you have tab merge, and you can still see that information. Okay. Were folks able to execute the merge? I'll bring the code back up. Man, you guys are so good at the emojis now. Nancy, I see that raised hand. I appreciate that too. All right. If folks want me to stop and pause, I'm glad to do that. Why don't we take our first restroom break? I think now is a good time to stop. That's all there is on appending and merging. I mean, it's challenging. You'll run into errors and challenges, but that's all there is to it right now. So those are the basics. And I think what we'll do is we'll come back at 7 o'clock, and we will jump right into loops and then some graphing, and then some regressions and t-tests. All right, see you in a few minutes. And I'll be here for questions if you need to ask questions. All right. It's about that time. Let's get back to it. Okay, so now loops. Loops are fun. Actually, no, loops are a potentially great time saver. They can also be a tremendous source of headaches, and so hopefully we can give you a few tips to keep the headaches to a minimum. But especially when you're new to it, loops are going to be challenging. That doesn't mean you shouldn't do them. They will save you a lot of time, but they can, they lots of cups of coffee per line of code in loop written. So it takes a little thinking and a little diagnosing. Okay, so a few things. First, before I can teach you loops, I need to teach you about macros. So there's two types of macros in Stata. There's the local macro and the global macro. Local and global macros are basically just another way of saying nicknames or aliases. It's a way of setting up a scheme in Stata where a set of letters, basically, sometimes letters and numbers, stand in for some other value. So you can use a name or some sort of signifier to stand in for some other value. That's very abstract, so let me just show you. So if I want to make a local macro, I would do something like, I could say local, let's see here, YOB for year of birth, and I can put in my year of birth, okay? And so now what this is going to do if I run this is it's going to store that local macro setup, okay? But or that connection between YOB and the year 1987. I then type display and say my year of birth is, and then colon, and then I put a backtick. So actually, let me pull this out of the quotes just so you can see it. I want you to be able to see that Stata changes color when you do this. So backtick is above the tab button for me on my PC and below the tilde. It should be near the escape button. That's a backtick. If you're working in Stata 16, it should sort of automatically give you a closed single quote, but if not, you should just close with a single quote. So what this is going to do is that this combination of characters tells Stata that what goes between these characters is going to be a local macro. Okay, so what it means is that the text that you're going to see, I've set up to be equal to something other, to mean something else, right? So if I say YOB, you can see that this all turns green because it's a local macro, and because I've set this up, Stata will understand that. Now, even if I take this local macro and copy and paste it inside of my quotes, it's not green anymore, it's red now because Stata's text highlighting highlights things that are in quotes, so it is easier to manage where your quotes are. Even if I do that, it's still going to recognize the local macro within the quotes. So if I run these two lines of code together, and you have to run them together from a do file, what's going to happen is I can see here that what it does is it stored this YOB. It took display my year of birth is YOB, and it changed it to my year of birth is 1987. Okay. Why is this useful? It's going to be useful in a second, I promise. One thing to notice is that if I say display in quotes, my year of birth is colon backtick YOB close single quote close quote to try to do the same thing, what I see is I get a blank. So Stata has already forgotten about the thing that I tried to establish before. The connection between YOB and 1987 is gone. So why is that? Well, the definition of a local macro is that it's only in Stata's memory for as long as the program is running, right? So it's not always available to you. It's only available to you when that program is running where you've defined it. Okay. By contrast, the global macro sticks in Stata's memory for much longer. So if I say global DOB equals 901, and I say display my date of birth is, and then instead of a backtick and a single quote, what signifies a global macro in this instance is a $sign. And so if I say $DOB, if I run these two together, I see that it's 901, the same as it was. But now if I say display my date of birth is $DOB, and then close quote, it still works, right? So the global macro stores global connections, as the name global sort of signifies, for a longer period of time. So not just when the program is running, but for the entire Stata session. Now, if you close out of Stata, you will lose that global macro connection, but if you've established it in your do file, it will, continue to run and continue to signify it every time. Okay? All right, so why is that important? Well, it's important. The global macro part you got just for kicks, because it's helpful and it's useful to learn about them when you're learning about macros. But the local macro thing is a huge part of what is going on with loops. Okay, so loops are meant to help us do repetitive tasks again and again. So if you imagine that you wanted to for every state in the USA, I don't know, divide its population by 100,000 or something, right? So you can get the definition of the population in hundreds of thousands. If you wanted to go through and do that manually, state by state, you'd have to go through and do it 50 times, right? But in the instance of Stata and a loop, you could sort of specify for each state, or you could specify the same task to be done, the same commands to be executed, but across different 50 states. That's maybe not a perfect example, but we're going to get into it, and you'll see some better examples. So the basic idea is there are frequently repetitive tasks that we want to do. It's easier to let Stata do those. We do a repetitive task, but with some small change, right? We change the state, we change the date, we change the number, something like that, and Stata can do that for us, and the way we can make the one small change is using a local macro. Okay, so the easiest way to understand this is forevalues loops. So this is where we loop through a set of values. Okay, these are sometimes called iterators. So here the iterator is numeric. So so for numeric iterators, because you iterate over a numeric value. So the way this works is we say forevalues, and then you set some local macro. So it could be banana, right? But it could also just be I. Sometimes I stands for sort of individual. The I subscript sometimes stands for individual. And so so let's just say for I, but you could also put for num. One good practice in writing loops is to give the macro that's going to stand in for some value a useful name, right? So in this case, why don't we do forevalues num, so that we just know we're going through a set of numbers. And why don't we say forevalues num 1 through 150, okay? And so you'll notice that I just used the slash to signify through. So this is going to count from 1 to 150 by ones, by integers. So 1/150. And I'm going to then open a curly bracket, which will automatically, if you're in Stata 16, open a closed curly bracket, right? So, and then you always want to just start putting those on the next lines, because loops run across multiple lines. And so here's what I've done. So this is the curly bracket. Now be careful, it's not a square bracket. This is the one above the square bracket. For me, it's next to it's the right of the letter P. Kind of looks like Jay Leno in profile, I always think. So in any case, it's the curly bracket. And so what you're going to do is within the curly brackets, you're going to put the command that you're going to want to do repetitively. Okay, so in this case, we're just to give you a sense of what's going on, we're just going to do a simple display command and say the current number is, and then a colon, and then we're going to do that backtick again. We're going to do num, and then we're going to do close single quote, and then we close the full set of quotes. Okay, so this is going to just show us what the current number of the loop is. This will give you a sense of what's happening in the loop. So it's first going to do this for 1, then it's going to go back to the top of the loop and do it for 2, and then it's going to go back to the top of the loop and do it for 3, and then it's going to go back to the top of the loop and do it for 4. Hopefully that's pretty clear. So if I do forevalues num equals 1 through 150, and I can see that I've very, very, very quickly generated that same phrase for all the different numbers, right? It ran through all those different numbers, which is really nice. And you can say, like, it would take me a really long time to say display the current number is, I've already taken more than the time that it would have taken me to just run the loop, right? So there's just the current numbers running. Even if I'm copying and pasting and grabbing this again, like, it just takes a very long time to do that. And I forgot the quotes. Yeah, it's a whole thing. Okay, so so what's really nice is that this code can run again and again and again, but changing what stands in for num. Okay, so this isn't a super practical example, but it does tell you that it does show you how Stata iterates. And to give you another sense of it, let's just do Stata as a calculator. Let's do display num raised to the third power. Okay, so now it's going to run through all of these. We'll just take this out, and it's going to run through all these, taking the third power, right? Stata does that calculation very fast. It would take you a really long time to do this. And so it's very nice to have that ability to run through things. Let me pause there and see if you have any questions. Okay. How does the local work here? So what you can think of it as happening here, Ash, is that it's like every time it runs through the loop, it's like it's saying local num equals 1, and then local num equals 2, and then local num equals 3, right? It's reassigning num to that local. All I'm doing here is that if I were to sort of display 5 to the third power here, it would work like that. And so all that's happening here is that, this is normal code, what we learned last time of just how to use Stata as a calculator. And so if we were, what we're doing here is just we're replacing a hard-coded number with a thing that can change, right? It's kind of like variables in algebra, where X stands in for something else, right? Something that can take on any number of values. We're just assigning it with like a sort of a placeholder. Here, the placeholder is num. It's also backtick num close single quote. Yes, Ash, it's saved as a local automatically rather than a global, right? So if I now go back here and say display num, I get nothing back. I get no result back. And so it's automatically saving things as locals. Yes, that's right. So the global I only showed you because it was a little bonus extra from what we were doing before. The local macros and the global macros are closely connected in conceptual space and Stata, and so it's always good to go over those and distinguish them. All right, so that's great. That's if you want to do stuff with numbers. And in fact, I can give you a good application. So hopefully you still have loaded in your data. And what we can see here is that there's a bunch of, if we look at like the different, so one thing you can do in the window here is filter variables by what's in them. And so if we do ASSC, stands for associates, what we can see is that we have an associates 4, an associates 6, and an associates 8. So this is how many students, what's the count of students who have finished their associate's degree within 4 years, within 6 years, and within 8 years. And so that's interesting to have. And we might want to do some thing to each of these variables in a similar way. So if I look at one thing you might remember from last class is the summarize command. If I do sum OMASSC for comma detail, I can see the distribution of number of students who have received an associate's degree across these institutions, right? And we see it has a mean of 255, yada, yada, yada. But maybe I would want to put this in counts of hundreds rather than ones, just because some of these get up into the high thousands. And so what if I wanted to just change these values to like a new variable that was everything written in hundreds? Do folks want to take 1 minute and try to generate a new variable that will be equal to the value of this variable in hundreds? I should say take a minute and try to do that. I shouldn't ask it as a question. So take a minute and try to do that. And the reason I'm having you do this is that the first step of figuring out what you want to do with a loop is figuring out what's the basic task that you want to do inside of the loop. Generally, this will be pretty obvious to you, but it's always good to start by writing the code for one example, right? So you know you're going to iterate over multiple examples, but it's good to try one example. If anyone thinks they've got good code for it, feel free to just drop it into the chat. We can see if folks are remembering some of the stuff from last time. Anybody got a guess? You can send it to me privately as well if you don't want other people to see your code. That's totally fine. Okay, no worries. So how we would create a new variable that stores the values of the associate's degree in hundreds rather than in current integers. We would say something like generate. I shorten this to gen. Gen OM. Oh, Nancy comes through. All right. So very good. So I'll just copy Nancy's. So Nancy has generate degrees in hundreds equals OMASSC4 divided by 100. That's great. So we run that, and then if we tab degrees in 100s, what we see, oh, I'm sorry, we shouldn't do that. We should sum degrees in 100s. So also, one tip, guys, is that if you're writing out a variable name in the command window and you hit tab, it'll give you options for which variables you can select. And if you if you have like a full set of letters that sufficiently distinguish it from all the other variables in the data set, it will just auto-complete for you. So if I do some comma detail, we can see now that these are in hundreds. So that's great. Okay, so now what if we wanted to do that not just for the OMAS 4, but also for OMAS 6 and OMAS 8? Okay, so this isn't a huge task, right? A very simple thing we could do would be to do this and then and then change these to 6 and 8. And the other thing we'd have to do is so that we didn't have 3 variables of the same name, which Stata won't let us do. We might want to do like something like add underscore 4 year, underscore 6 year, right? And then underscore 8 year. So in this instance, it's not that time saving of a task, but it might be something that you would have, like, imagine if you had not just 4, 6, and 8, but 4 through 30, right, or something like that. You would want to be able to do this in the same way. And so this is the task that we're trying to replace with a loop. And so one thing we could do is say for values, let's say num equals, and then we're going to say for, oh, okay, so this is different. We can't just do 4/8 because that would do 4, 5, 6, 7, 8, and we don't have OMSC 5 or an OMSC 7, so that won't work for us. So what do? Well, Stata gives us the option to do a jump, like skip counting. So 4 count every other one, so 4 by 2 through 8. So that gives us 4, 6, and 8 if you just put it in parentheses. So that's great. That's a great option. And then I only need one of these lines of code because the thing is going to change in between. And so if I copy this and bring it into my uh, into my loop, now I have to think about, okay, which parts of this need to change because they're going to be different. They're going to look different for the 6 year and the 8 year. Okay, well, we can see here that 4 year is going to be different each time we run through it. And we can also see that OMA SSC 4 is going to be different each time we do it. We want that to be sometimes to be 4, sometimes to be 6, sometimes to be 8, right? And so now if I'm going to just quickly delete the variables we already created because I already created them. Oh, I guess I only created this one, but in any case, I'll just drop it just to get out of the way. And if I run this little piece of code, now I see it generated 3,000 missing values each time, and that makes some sense. Those are all missing on the same things. And if we look, we see now that we have these degrees in hundreds 4 year, degrees in hundreds 6 year, degrees in hundreds 8 year. Any questions so far? Okay, so why don't we real quick give you guys a challenge and ask you to try to do the same thing for OMASSC 6. I'm sorry, not OMASSC. Let's do it for bachelor's degree. So there's bachelor's degree with 8 in it. Why don't you go find the other bachelor's degree variables? Remember, don't use the ones with X's. Those are just in imputation flags. And see if you can do the same thing. Divide by 100 or 1,000, whatever you want to divide by, and just create a little loop that will do that for you. Go ahead and take 3 minutes to do that. Okay, that's been about 3 minutes. Hopefully you guys sorted that out. So, the way you would do this for bachelors looks very, very similar. You would say batch 8. And let's see here. I'll change this to batch degrees in hundreds. So, and I'll run this like this. Okay, great. So I see bachelor's degrees in 100 4-year, bachelor's degrees in 100 6-year, bachelor's degrees in 100 8-year. Okay, so that's a nice loop. There's some other types of loops that we might want to do though. So, Stata also has what's called a for each loop. So you would say for each instead of for values. So as for values sort of implies, you're using numeric stuff. For each is going to do other kinds of objects that you might be interested in. The most obvious object that you might be interested in is a type of variable, right? So you might want to loop across variables. You might be taking different tasks across variables. So we might say for each var, which I generally stands for variable list. So again, var is going to be your local macro. And in this case, instead of saying equals, we're going to say of or in. There's sort of two different cases when you do it, but you're going to say for each var of, and then you can say var list, right? So for each var of var list, and then you can list a set of variables. So this var list stands for variable list. So what if we wanted to, rather than go across the years, what if we wanted to go across the types? So if we said for, we could take the certificates, the associate's degrees, and the bachelor's degrees, and whatever this one is, across all 4 years. Actually, I'll do this one too. And what if we wanted to make some change across all of these 4, right? So all these 4-year measures, okay? Again, maybe we would want to just divide it by 100, right? But in this case, the number isn't the thing that's changing. It's all this name stuff, all this letter stuff, right? And so looping through that is a little trickier. But in this case, what we can do is just list the different variables. You could, of course, do this with the numbers as well, but I just wanted to show you a number example before. So this, there's plenty of different ways to skin a cat with this stuff, but in this case, this is a good example of the different things. So you might say gen for, let's see here, let's say credential type. Actually, so the thing we want to put here in the name is we'll say cred, and then we'll put the name of the var. So let's say cred 100 var. And what this will do is it'll create a variable that's called cred 100, and then it's followed by this name, so this piece of text here. And so I will say var divided by 100, and this is the same concept of what we're doing is we're looping through these different variables and dividing them by 100. And so if I run this, I can see now that I've got a variable called cred 100 ohm cert 4. I've got cred 100 ohm assoc 4, cred 100 ohm batch 4, cred 100 ohm whatever, the rest of these, right? And you can see that. And you can see that these cred 100 variables have been divided by 100 effectively. Okay, so that's a for each loop with a var list, but there's lots of different things you can do with for loops. So if you say help for each, you can look in and it'll show you that there's an option for in or of, and this is the local macro name. So so you can do it of locals, of global macros. So your global macro could be a list of items. You can do it over var lists. You can do it over different types of lists. Okay. And then in refers to any list. So let me just show you quickly how a for each in loop works. So this makes it the most flexible possible. So if you say for each thingamajig in popsicle Darwin 38, and then 7, 6 star percent pound or pound K. Okay, so what this is a list of random sort of things, and because there's not really anything I can do with them, I'll just show you the displaying of it. But I'll say display. You can put anything in here, like I'll say thingamajig. Okay, so you can put anything in here like thingamajig, and then hopefully this will work. So popsicle Darwin 38.7. So it's able to iterate over sort of more flexible sets of lists. So that's really nice. One thing that's very useful for the locals that always trips me up that might be useful for you is sometimes you want to know like what the values of a variable are, and you want to loop through all the values. So like I was saying, if you wanted to do states, right? So if you wanted to say, so if we say tab state, did I? Oh, it's stabber. I'm sorry, stabber. So tab stabber, we see all the different states here. And what if I wanted to do something on particular states? I could say something like for each. I'm sorry, what I would want to do first is say levels of. Levels of is a very useful command. And what levels of is it tells you all the different levels of the of a variable. So if I say levels of stabber, it gives me back all these different things. But the other nice thing about levels of is that it allows me to store those as a local macro. So I can, if I use this option local and then I put in a macro name, I can store the values. So if I say levels of stabber and I say local parentheses state names, I can do that. And now if I say for each loc, or I could say state of local state names, and then I say display my favorite state is, and then say state. I can see that what this will do is run through all the different states. That can be really helpful, but the thing I want you to notice that has tripped me up for a long time and is a little weird is that before, when we've signified locals, we put them in this backtick followed by a closed single quote. And here, all we have to do is type local and then state names, the name of the local, which we created here, but without putting the backtick or the single quote. That can be very confusing. So this is the one instance where you don't have to do that. And the reason you don't have to do that is because you're declaring to Stata that this next thing that's going to come in this list is a local. Just like up here, you said the next thing is going to come in a list is a variable list, a list of variables. So what it knew was going on here was that it was going to be looking at variables rather than a random list. Here, when we use for each in, we don't specify a list type. We just give it a list of random stuff. For each in is also really good if you have numbers that are in a weird sequence, right? So here we were we were skip counting by 2. Here we were counting by 1. But if you wanted to skip by 3, then 4, then 7, then 10, right? Or if you wanted to just have a random array of numbers that weren't in a very discernible pattern, you could also put them through for each. Okay. I think that's enough for loops, unless you guys have questions. Otherwise, I'm going to jump to some graphing.
How much do the lines, the blank lines, really matter in the loop?
They don't matter a lot for the function of the loop. I use them because visually I find it easier to read my code and understand what's going on if I indent effectively and
so it could
I
all
also
be
spread them
in one line. It's not going to error.
I think it will error if you do it all like this. I don't think it can do that. I could be wrong. Yeah, it won't do that. So it has to go at least one line, but it doesn't necessarily have to be indented. And it doesn't necessarily have to be skipping more than one line. So that that's giving me an error just because I've already created it, but yeah. So you need to drop at least one line, but I find it much better, especially as your loops get bigger. Nancy, let me just look at this real quick. Hold on a second. All right. Sorry, hold on a second. Nancy, do you mind if I share this with the group? Ooh, I'm trying to keep your privacy, but if you, okay.
Yeah. And it's fine. I can save it for the end. For some reason, it's like counting and not allowing me to run anything.
So so you're saying what's the problem here? The state names thing in particular?
Yeah, it's just not allowing me to generate anything that I'm
Oh, it's
putting.
not spitting anything out, like it's not
Yeah,
returning any
and it's
result.
counting on the left side, so I'm not sure if that's connected.
Interesting. Is it still running? Like, is there still like a little bar spinning on the bottom right hand side, or does it seem to have stopped running?
It seems to have stopped.
Okay. So your macro. Oh no, that should be good. Interesting. You may have stumped me. So did the thingamajig thing work or no?
No.
Did you generate new variables, or that also didn't work?
Didn't work. I might just close out and start Stata again really quick.
That might, yeah. Why don't you try that and see if it works? That's very odd. Oh, you know what you're doing? I see what you're doing. So you're copying and pasting this into the command line rather than running it from do file. Is that right?
Yes.
That'll be the problem. So it's very, Stata won't run a loop that way either. Are you still there? Okay.
Yep, got it. Thanks.
Okay. Yeah, no worries. I just want to make sure that my stuff didn't cut out here. Okay. So on to graphing. Actually, one more tip, guys, is that if you're trying to debug your loops, that can be a really tough problem. So especially if you run things multiple times, one thing to just do is if you say set trace on, what that'll do is when you run a loop that has like some sort of weird error, right? So if I were to just take this out and already have this variables created, what I can see is that it gives me where exactly in the loop that things went awry. I can see what the error is. Normally, Stata doesn't show you what the error is within your loop, and so that's a problem. So okay, so I'm going to say what was going to do? Set trace off. Okay. All right. So graphing. Graphing is fun. It's maybe the most fun part of Stata, at least for me. Also called plotting, right? So imagine that we wanted to show a histogram of the number of students in a cohort across the schools. So all we would do is say something like histogram, and then our cohort variable is OMCHRT. Oh no, I'm sorry, OMRCHRT. And I'd go back here and I'd write this in, and like blech for many reasons. Okay, whatever this background color is that's going on, you got these weird scientific numbers. This thing is just like one long bar with like a couple shorter bars, and then like all this white space. So a lot of stuff going on. This is not a human readable thing. many different things. So what we're going to start to show you is a bunch of different ways to make this look nice. A lot of people believe you can't make graphs look nice in Stata. I don't think that's true. You just got to know the tricks. So the first trick is to install some schemes. So I'm just going to go grab these schemes from here. I'll put these into the chat as well, so you can do them. So schemes are user-written sets of colors, default colors that Stata graphs will use. And so I really like the 538 scheme. It tries to mimic the 538 figures that you see online. Blind schemes is also a really nice set of schemes. They both have really nice colors, and they have options for making things visible to people who are colorblind, which is a non-trivial portion of the population. And so that can always be good. Bird is a nice one. And then there's some other ones thrown in here for good measure. You can see a bunch of these different scheme styles if you want. If you go to this go to these websites. I put those also, I think, in the chat, and I'll leave them there, while we're doing this. Maybe I didn't put them in the chat. I'll put them in the chat. Okay, great. So hopefully you can install those. Why don't you guys go ahead and install those, and hopefully they'll work for you. And while you're doing that, let me show you what happens if we limit ourselves. So one thing that's going wrong with that picture is just that we have a couple of outlier schools that are way out there in the tail. I can't spell OMCHRT detail. And so we've got this 120,000 student cohort that's way out there, and that's when you have to also graph that with a value that's 1, that's really hard. That's also like 5 or 6 times the value at the 99th percentile, so the absolute highest is way farther to the right. So one thing we could do is just limit ourselves to, say, like something around the 95th percentile, and that can make life a little bit easier. So what I did here was I said keep OMCHRT, OMRCHRT if OMRCHRT is less than 10,000. So now we're only going to graph the observations where it's less than 10,000 students. That cuts off some of the data, but it allows us to see more of what's going on in the data that's there. So we can see this is very skewed. It mostly consists of small schools. Okay, great. And so when you look at this instantly, you can see that schools with 8,000 students are very atypical, right? And this is before we viewed and excluded the ones with 120,000 students. But it still looks gross in a lot of other ways. So if you've got your blind schemes installed now, let me just bring these over. Or sorry, your 538 schemes or your blind schemes or whatever you want to use. If you've got them installed now, then you can, one way you can see if they're installed is you can type graph query and comma schemes, and it shows you the schemes that you have installed. I've got a bunch of them installed. You may also have a lot of them installed. Doesn't matter which ones exactly you have. But what this tells you is that what you need to put in a part of the command that I will show you in just a second in order to use that scheme. So you're going to use that name. So if we wanted to change our new histogram where we said histogram OMCHRT less than 10,000, if we wanted to change that so that it looked a little bit nicer, we could add comma, scheme, and then 538. And if we do that, we get a graph that looks a lot nicer. Okay, that already looks a lot better. What it does is it drops the background to all white. It gets rid of that weird turquoise color. It makes the bars a default sort of gray with an offset outline color. That all helps greatly. That's really nice. And so we've made one step in the right direction just by changing the scheme. If you want to have a sense of what some of these other ones look like, you can go ahead and just sub out. So one of the ones that comes with blind schemes is called PlotTig. I like PlotTig a lot. also looks very nice. It's got a sort of white set against the gray with the white grid lines. That can be very useful. And then if you really want to, you can, try some of the other ones out. I encourage you to test them out. 538 and Plotdig are the ones I use 95% of the time. I used to use Bird. I think Bird is a little oversimplified. It looks better than the default, but I think it's not as nice as the other ones. So, but feel free to play around with the ones that you see on your graph query. Play around as much as you want. They have one that looks like The Economist. I've never gotten that to look good, but if you're a fan of The Economist, that can be kind of fun. Economist, the magazine. So other stuff that we might want to do to this graph. So we might want to add, say, a title, right? So if we say hist omchrt scheme 538, and then say title, number of students in cohort, this gives us the result where we have number of students in the cohort. If you don't want it over here, but you want it over here, I believe you can just add the option span. I think that's right. Oop, no, maybe not. Maybe it has to go inside this, so comma span. Let's see. Yes, so if you say span, it normally puts margins on them, but this gets rid of the margins and allows you to do it. What about if you want to make this bold? I think you can say BF. Let's see here, BF. I should improvise. So BF, I think looks like this. I could be wrong. Let's see. There you go. Bold font goes in that like that. Okay. So you can bold the font by putting it in curly brackets, starting with BF colon, and then writing the rest of what you want, and then closing the curly brackets. Yep. I will grab. I'll put. I'm also going to post. I'm going to send around this do file at the end of everything as well. Here's the code. Okay. So okay, great. So we've got some things that we've added there. What about if you wanted to add a subtitle? So you could say something like, I'm not done writing about this graph yet. Okay. So we could do this. So one thing we can see is that this isn't span, so it's not all the way over to the left. So that can be a little annoying. I'm going to just take span out of here for now. Okay, so these are offset. One thing that's kind of annoying about this is that it's the same size as the bigger one, and generally you want the smaller title, the subtitle to be the smaller title. And so one thing you can do is inside the parentheses, but outside of the quotes, you can put comma and then say size and then say something like small. So that makes it a little bit smaller, a little bit easier to read. Okay. Now, what about if we wanted to change this to a human readable thing? By default, this will show the label. So one thing you can do is change the label of the variable. But another way to do it is to just use this option called xtitle. So if you do xtitle and say, let's see here, cohort size or something like that, we get a thing called cohort size here. Now this can often be a little smushed up against the numbers, and so if you want to wrap to multiple lines, what you can do is put a space and a quote and then a close quote and then I'm sorry, a quote, a space, and a close quote, and then a space, and then open a new set of quotes, and that'll put two different sets of lines. So I use that as a little hack to get this down farther. But of course, if you wanted to actually wrap your things, you could say first line. You can write whatever you want, but the thing in the first set of quotes will go on the first line, and the thing on the second set of quotes will go on the second line. So that's a really nice thing to be able to do. So I'm going to bring this back to empty so that it will write nice, and then okay, great. So what if I want to change the color of the bars in my histogram? I can just say color, and I can specify orange if I want to, or I can specify any number of colors. If you Google for Stata color palette, generally if you write a number in, a color in, you can get that color. That they don't always look good, but sometimes they do. Another thing you can change is to move from coloring just the whole thing to coloring the inside and the outside differently. So if you want to color the inside, you use F color for fill color. We might say something like yellow. And for the line color, we use L color, and we might say something like black. And if we do that, we get a nice sort of outline thing that really pops. Another particularly nice option or good option for histograms to know about is how to get yourself, rather than densities, to get yourself frequencies or percents. So if you want a frequency plot, a histogram where every bar measures the frequency of each thing, you can see now these are frequencies. They're not anymore scientific numbers. And the reason for that is that you now got this bar represents a little over 800 schools. This bar represents somewhere between 600 and 800 schools. This bar represents somewhere between 400 and 600 schools. This bar represents somewhere between 200 and 400 schools. Okay, so that's a lot of options. Oh, and let me do percent. So you might want the percentage distribution as well. I always forget you need to write out percent fully. So, and here's the percentages. So this says that this bar, right, these folks in the close to zero represents something like 24% of the 23% of the data. Okay, I know this is moving fast, but hopefully giving you so how do you change the scientific numbers? It takes some tricky formatting. Ash, if you send me, I'll have to look it up, but if you send me an email, I'll look it up and try to find out how to do it for you. I think in general, it's hard for people to interpret densities, and the reason that happens, the reason that scientific notation happens is that you're displaying densities. So why don't we move to bar graphs? So the most basic bar graph is graph bar, and something like you want to get the number of observations per group. So you would do something like graph bar parentheses count, and then comma, and then over, and in this case, let's do over sector, right? And I'm going to remember to put my scheme in here, 538, and I'm going to plot it. I'm going to run it. So sorry, just here quickly is graph bar parentheses count, comma, over parentheses sector, scheme, spelled it wrong, scheme 538. Okay, and I do that, and it gives me these bars. Looks kind of interesting. A few things wrong with this. So, one thing is that this is like lowercase. These are all overlapping each other. I don't really know the height of all of these bars. And so, so one thing I might want to do is I might want to change this to a horizontal bar graph to make it a little bit easier to read. So I would switch from graph bar to graph H bar. So now it's very nice when you have long value labels to have these on the other axis. And so this is much easier to read. If I want to see the totals on top, I might say something like B label total. Okay, and that B label stands for bar label, and it gives me the totals for the bars. And so now I can see these. I can kind of see them. That might be the right size for you, depending on how salient you want them to be in your graph. But if you wanted to change the size within here, you can type within this parentheses. You can type size, and you could maybe say med small. So that stands for medium small. It's like one up from small, and that makes them a lot bigger. There's a whole sizing chart on the Stata cheat sheets. So if you want to look through that, that's a great resource for this stuff. In terms of text sizing. Okay, so I'm just going to set this at small. And what else do I want to show you? So that's a rough sense of bar graphs. Oh, I can also change this like Y title to frequency, or let's say number of colleges, something like that. You can never keep track of it's the Y. So when you flip it to a horizontal, the Y, so the X becomes the Y, but you can sort of see here that we've got number of colleges changed now to this. Okay, so that's just a regular counting graph. So we're just counting the different number of institutions per sector. But what if we wanted to sort of measure some value across the different sectors? So if we said graph bar, and then in parentheses we put mean, that's the statistic we want to calculate, and we need to take the statistic of a particular variable. So in this case, why don't we just make it of the cohort size? So if we look across the cohort sizes, we say graph bar mean OMR CHRT, and then we can still say over sector. And because we're doing the sectors, I'm going to keep this at H bar. I'm going to change the scheme just to give you a sense of what the other one looks like. So to plot tag, and I'm going to say B label total size small. Okay, and so now I'm going to run this. And now I can see that these public less than 2 year, private nonprofit less than 2 year, private for-profit less than 2 year, sector unknown, and administrative unit don't have any value for the cohort sizes. So the only ones that have values for the cohort sizes are here. But we can see that there's a, the public 4 years are very big. The public 2 years are very big in terms of their cohort sizes. The non-for-profits 4 years are smaller. The private for-profits are relatively bigger. We could change the sizes, or we could change the statistic we calculate by changing what goes in here. So we could move from mean to median, and now we get medians, and we see that this sort of the private for-profits sort of came back down because they have some very big schools that are pulling their cohort sizes up. And we can also see now that the public 4 year and the public 2 year have switched spots. Let me pause here because it's 8 o'clock. I know I told folks I would go to 8 o'clock. I'm glad to keep going if you want to stick around. Otherwise, I don't want to bore you or take up too much of your time. I know this is a lot of time to ask, but I'm going to keep plugging along if you want to keep going. But you should feel free to go. Okay, so let me see here. Why don't you guys look through the graph H bar or graph bar help file, so help graph bar, and see if you can find out how you would do for these same set of variables, calculate show a graph bar that calculates rather than the mean or the median, calculates the 75th percentile for each school of the cohort size, and see if you can create a graph that way. Let's take a minute to do that, a minute or two, maybe more, if you need it. See you, Bradley. Thanks for joining. Thanks, Lexi. See ya. Thanks, Garrett. Appreciate it. Thanks, Roy. Okay, so hopefully when you looked in the help file, you were able to see down here in, you can see that it asks you for the stat. And if you look down, let's see here. This is trickier than I expected. Where is the stat? Well, I guess it tells you right here. So where stat can be any of mean, median, P1, P2, through P99, sum, count, percent, min, max. So so those are all options for you. So what we would do if we wanted to change to the 75th percentile is we would say something like P75. Okay, and that gives us the 75th percentile of each group. Okay, so talking about 75th percentiles, another great type of plot to do if you want to see something a little bit more manageable than a histogram, but a little bit more informative than a bar graph, would be a box plot. So you might say graph box, OMRCHRT, comma, over sector, and let's do scheme plot tig. And what we can see is that we get this weird looking thing. It's got a lot of dots. It's got very squished boxes. These names are all over the place again. Same problem that we had with the other plot. So a couple of changes we're going to make. We're going to change graph box to graph H box. We're going to add this option called no out, which adds no outliers, and the dots are outliers. So if we do just those two things, we can see that we get a much better looking graph. And you can see it adds this note that says excludes outside values. So you don't have to worry too much about that. This box and whisker plot definitions of the whiskers can be tricky, but you can look up in the Stata help file for graph box exactly how they calculate it. This is called the upper adjacent value. This is called the lower adjacent value. Those have a weird definition, but a lot of people think they're the 90th and 10th percentile, but actually they aren't. So that's good to know. At least in Stata, they're not. Okay, but what this is really nice to show us is that it shows us the 25th percentile, the 50th percentile, the median, and the 75th percentile all in the graph, and then it sort of gives us some sense of the outer extremes of where the data is. So we can see that the public 2-year has some really big values in it, and public 4-year has some really big values in it, and also some really low values. And so we can sort of get some sense of the distribution of the data. It's not the full distribution, but it gives us some sense. Okay, but what if we wanted to have like overlapping distribution? So we wanted to see exactly how these distributions overlap each other. Well, we do a couple of things. One is we would try a kernel density. So kernel densities are harder to understand. So you can't do F color with everything. So with H bar, the coloring is a little bit more complicated. I'm glad to show you where in the documentation, Naomi, but it's tricky. I always basically every time have to look into the documentation about how to change the colors of bar graphs and It is totally possible to do, but it just takes a little doing. And just the help file, if you read through the help file thoroughly, it should. Or if you look at the Stata cheat sheets, it may also give you a sense of how to do that. All right, so so the kernel densities. Kernel densities are very much like histograms, except instead of being bars that go up into the sky, they're lines that sort of trace the density of the curve, of the distribution at each point. So we would say k density, OMR CHRT, scheme plottig, and we'll see a kernel density of the OMR CHRT. Again, we get this really skewed thing, and so we might want to limit ourselves to if OMR CHRT less than 10,000. And that's, looks very similar to the shape of our histogram, but a little bit different. But we can see that the density sort of varies across the distribution, but sort of most of the mass of the distribution is over here, and much less of it is down here. Okay, gives you information by default about the type of kernel that it uses. These are all sorts of tricky things. The only reason that you might be interested in the kernel density is if you wanted to compare distributions. I mean, maybe not the only reason, but probably for the sort of most basic things that we want to do. We would say if OMCHRT, OMR CHRT less than 10,000, and let's just do this by sector. So let's say if and sector equals 2. So this is just going to give us the second sector is what is private nonprofit 4 years. So let's just compare the private nonprofit 4 years to the public 4 years. So there's, oh, I should put the scheme on. Scheme plotting. So if I run this like this, that's just one group. But if I want to put two at the same time on top of each other, I add this thing two-way to it, and then I wrap the first command in kdensity in parentheses, and then I can go to the next line and do the same thing. So, but remember, I used the 3 slashes to go to the next line so that it's all one command. And so this I'm going to change to 1. So what this is doing is it's going to do one graph where it's only graphing the folks in sector 2, and it's going to do another graph where it's only graphing the folks in sector 1. This condition is in addition to limiting ourselves to just all the institutions which are less than 10,000 students in the cohort, right? So when I plot these two together, I can't do scheme within side of both of them inside the two-way, so I'm going to pull this out to the further thing. So 1 second. So I'm just going to, outside of the 2 sets of parentheses, I'm going to say comma scheme 530 or plottig. Okay, and I run this, and now I see the 2 different distributions. These distributions look way different to each other, right? And what it tells us is that there's way bigger institutions that are public and way smaller distributions, or way smaller schools in the private nonprofit, and you can sort of compare the 2 distributions across each other, which is really nice. There are ways to change these labels. There's ways to change this label, like we've learned before, this label as well. The way to change this label, I believe, is to do something like label 1 legend. No, I think it's legend. Let me see here. Help graph. Okay, help 2A. Let's see here. Legend. You know what? I will figure this out and send out an email if you guys are interested, or if you're interested in learning, let me know. I knew I would get stumped on something. I always have to look up legends as well, but it is possible to change the legends. Maybe it's like this: legend, label 1, test. Or what is it? It was private, NFP, close paren, label 2. open paren, public, for your close paren. Let's see if that works. So it's tricky because you have legend, which controls the legend, and then it controls the first label within its own set of parentheses, then it controls the second label within its own set of parentheses. I believe that's how it works. Hey, what do you know? So there you go. So you can control the legends that way. You can also control where the legend is. So within the broader legend set of, and you can tell which set of parentheses you're in because they both turn the same color. So within those, you can say, what did I want to say? Position, so POS. And this is positions as time on the clock. So if I wanted to go at the bottom, I would put it at 6 o'clock, which can be useful. And then, but now it's 2 rows, and so it's still up kind of high. But what's nice is that gives you more graph space, which is useful. And so if I also want to make it all just 1 row, I could say rows 1, and then I'll put them next to each other rather than top of each other. You could also say calls 2 for 2 columns. Okay, so that's kernel densities and also controlling legends. One last, there's lots of different plots. We don't have obviously enough time to show you them all today. But another thing that you might want to do is a scatter plot. So a scatter plot is very, very useful plot when you have 2 continuous variables. So let's just pick out 2 2 values. So let's see how associated bachelor's degrees and associates are. So I'm going to take OMASC and OMBACH, and we're going to do scatter, and I'm going to do scheme plot take. So let's see how this works. So this is not a very informative scatter plot, partially because we have these extreme outliers here. If we pull out let's just do this if OMR CHRT less than 10,000 again, and we can sort of zoom in. We get a little bit more, but we see really most folks, if they're awarding bachelor's degrees, they award 0 associate's degrees, and if they're awarding associate's degrees, they're generally awarding 0 bachelor's degrees. There's some that are in the middle here, but generally not a strong correlation between these two. But still, you can see the bachelor's degree goes on the x-axis, the associate's degree goes on the y-axis, and so that can be a useful thing when you're doing plots. A scatter plot is a very nice plot, very easy plot to show. You folks have questions about plotting before we jump in quickly to just t-tests and regressions? We'll do those in 5 minutes, so not too much ahead of us. I know it was very fast on the graphing, but the key with graphing is just seeing someone do it. It's and if you run into any issues, you can always look them up or look on the cheat sheets. Okay, so let's jump into regression because it's the most. Okay, thanks, Sam. Have a good one. Regression is very similar to scatter plots. So let's go ahead and do that. So the code for regressions is very similar to scatter plots. So we're going to take our independent variable, or sorry, our dependent variable, and that goes first. That's y. Then our dependent variable or variables go here, and that's x. And you could have x1, x2, x3, x4. And so the simplest regression command here is just regress OMASC or OM associates 4 and OM batch 4. Ooh, no, I just ran the whole thing. All right, let's stop that. Okay. So if I do this, oh, I should make this bigger so you can see nice output. Okay, so I get back this regression table where I get the coefficients. Hopefully you're familiar with regression. I get the coefficient on the number of bachelor's degrees. So for every one increase, or one person increase in bachelor's degrees across the sample, we see an associated 0.069 people increase in the number of associate's degrees granted after 4 years across these institutions, right? We can see our R squared and our adjusted R squared. We can see the root mean squared error. We can see the number of observations that were used there. Also, a very common thing to add is if you want heteroscedasticity, robust standard errors, all you have to do is do comma robust. Or if you're so inclined, you can do HC2. Another way of getting robust standard errors that are very similar but not exactly the same. HC2 is not in the documentation though, so I like to make sure people are aware of it. And so, yeah, so these, these report out the R squared root mean squared error as well. They just give you the heteroscedasticity robust standard errors instead. Yeah, so that's one thing you can do with regression. Another thing you can do with regression is you can include what are called factor variables. So if we wanted to include in our regression a set of indicators for for the sector of the school, we would put something like I.sector. So what we get here is the coefficients on each individual sector. So it's a little hard to see these here because of the way my screen is crunched, but this is private non-for-profit, private for-profit, and the different private non-for-profit, probably 2-year and 4-year, the different sets. And you can see what happens to the number of associate's degrees going up or down relative to the sector. This isn't particularly meaningful just because we're talking about number of graduates rather than percentage of graduates, but what this tells you is that these are probably smaller schools on average relative to the public 4-year, which is the omitted category. If you want to control the omitted category, you can do I believe it's IB, say 3 or 4 or whatever you want to do. So these, remember the sectors have numbers. So if we say free sector, they all have different numbers. And right now, the thing that's serving as the out group is group 1. But if we said IB4, it should make the public 2 years be the out group. And so now you can see we have public 4-year in there, and then the public 2-year gets dropped out, and the private for-profit just because of the way the data is sitting. But you can control which is your base or reference group by changing the B3, B2, that sort of thing. Okay, and then of course you also get here, this is an obvious thing, you get your standard errors. I should have pointed you to. So you get your coefficients not only, but you also get your standard errors, and then you get the t statistic associated with your values and the p values as well as the 95% confidence intervals. You can control these confidence intervals. I just suggest you take a look at the documentation for that if you're interested. Okay. And the last thing you could do is a t-test between, say, 2 groups. So this is a very simple thing. Let's try to create 2 groups, or let's see if there's something that has 2 groups here. So probably HBCU or not, right? So whether or not you're an HBCU, historically black college or university, we could see if the cohort sizes are different across HBCUs and not HBCUs. So let's do t-test, and we're going to test whether or not the value for associate's degrees, let's do bachelor's degrees, are different. The numbers are different across. So if we say t-test ohm batch 4 by HBCU, this will look at the ones that are HBCUs and the ones that aren't. And what we can see is we get the mean for the groups that are HBCUs, right? So those schools tend to have a number of bachelor's degrees of 208 versus the rest, which have on average 515. Remember, there's lots of big schools. This is, it tells you sort of that historically Black colleges are smaller schools, likely. And so we see a difference of 307 across the groups. These each come with individual standard errors as well as confidence intervals. We see that these confidence intervals don't overlap, which tells us that they're probably different. We also see that we get a t-statistic of the difference of negative 2.98 with an associated probability that you would find such a difference in a world where the two groups had the same mean number of people in their cohort of 0.0029, so very small chance that they're not different. And so that's how you can do hypothesis testing with a simple t-test. Okay. Hopefully that was pretty clear. Trying not to keep you guys too late, but glad to answer any questions you have. Otherwise, that's it for me. Alrighty, well, I think, yeah, Zara, I will post a recording for this too as well. Yes. Hope you got the last one. Did you get the last one? I think I sent it in the email. Oh, okay. Check the email. Maybe I didn't put it in the email, but if I didn't, I will make sure to. I also tweeted it, so if you want to check Twitter before I send it out tonight or tomorrow, you can find it there. Alrighty. Well, thanks everybody. Hope you have a great night, and thanks for joining me. For those of you who are joining on Wednesday, looking forward to it. Okay, great. Talk to you soon.